we have a raster of NDVI, but what if you needed to calculate it yourself using data from satellites? We can do that very simply using raster math in R. So NDVI is an indice that takes in two different spectral bands, B5 and B4, and you have to do a very simple calculation to calculate NDVI. So I'm going to show you how to do that. We have data for both the B5 and the B4 band, so we can do that directly in here, and if we do it correctly, that means that the value should match what we have in our NDVI file. So first we need to import our B5 and B4 data. So let's go ahead and import these data so that we can calculate this vegetation indice. So let's pull open the data folder and see where the data is saved. So here is the data portal for the raster module, and the two rasters that we're going to be using is the b4_nyc.tiff and the b5_nyc.tiff. And you can gauge by the title that we're calculating NDVI for New York City. So we are going to go ahead and import these data. So we need the raster function, and then we can just type in the file name. Type in or copy, whatever is easier for you. Let's import that. And then the same thing, we're going to do the same thing for B5. Okay, let's plot it really quickly and see what these rasters look like. So there's B4. You can see if you've been to New York City or if you've looked at a map of New York City, these should look familiar to you. We can also look at B5. There you go, there's B5. So let's go ahead and calculate NDVI using these two rasters. So you'll remember from the PowerPoint that NDVI is an indice, so we need to create a variable, and essentially it's band 5 minus band 4 divided by band 5 plus band 4. So band 5 represents near infrared data, and band 4 represents data for the red wavelength. So let's go ahead and do this calculation. We need a pair of brackets, and then in there we do the calculation in the numerator, which is band 5 minus band 4. And it's really as simple as doing B5 minus B4. And then we can divide that by B5 plus B4. So let's run that. And that's it, we're done. So doing raster math is really that simple, but the important thing to note is that all of the rasters have to have the exact same parameters. So I'm going to show you what I mean by that. When I say parameters, I mean they need the exact same, well, let's pull up in the B5 raster. They need the same class, of course, they need to be a raster, the same dimensions, resolution, extent, reference system, and all of that needs to be the same. And let's see if B4 matches it. And obviously it does. You'll see that all of the parameters are the same except for source and names, which makes sense. Doing this manually is almost impossible to do if you have a large raster or if you have hundreds of rasters. So there's a really convenient function that we can use called compare raster. So it's pretty much just called compare raster. And you need to input a couple things. You need to input the name of the two rasters that you want to compare. So for us it's B4 and B5. And you can see that they're exactly the same. Let's do the same thing for a different raster that we used in this module. So I'm going to re-import land surface temperature. And then I'm going to replace compare the B5 in compare raster with LST. and it tells you exactly what's different. So they have different extents. So this is a really useful function to use if you're doing any sort of raster math and you want to make sure that the rasters are the same. So always keep that in mind. Now we have the NDVI. Let's take a look at it. And that's plotted as well, actually. NDVI. So there's our NDVI. You can see areas where there's more vegetation and areas where there's less vegetation. And if you know New York, you know this makes a lot of sense.